This comes from trial number 2 in the kinematics and statistics SAC, and it's question number 3 only, so it's about the base jumper. Originally, part D in the question wasn't included, so as a result, it made it doing the question quite difficult. Okay, so it starts off with a jumper jumps off a fixed bridge and, neglecting effective air resistance while in free fall, determine the speed when the parachute's open, and the parachute opens after 62.5 metres. So we have constant acceleration of 9.8. I'm assuming down is positive. So the distance down is 62.5, A is 9.8, U is 0, and solving for V I get 35 metres per second when we get to this point. Having descended 62.5 metres, so we've gone down to 62.5 metres, we then open a parachute and motion is retarded by this variable force. So this is an acceleration that is opposite to the direction of motion. So this is going up and the acceleration is g going down. So acceleration is g minus the retardation, which is this. Then looking at their answer, I've replaced A with dv dt, and I've got an expression over here now, taking out negative 1/16th and g, because that's what they did, gives me that expression, which is their expression. To find terminal velocity happens when she falls and falls and falls and falls, and then gets to a point where she travels at constant velocity, and that means acceleration is 0. So I can set this last expression, which was my acceleration expression, equal to 0, which means this is equal to 0, which means V is 4. Part D talks about the drone. So at the same time as the base jumper opens their parachute, so the jumper jumps off the bridge, there's a car on the bridge. The jumper jumps off the bridge, and when they open their parachute, the drone moves up. And the drone moves up using this velocity time graph. So the area under this curve will be the distance. And during the first 4 seconds of the motion, this is the acceleration, and then it gets to a constant speed of 4. So if it travels for a distance of capital T, then that's 4, and this is T minus 4. So I can move from acceleration to velocity by taking the antiderivative. I know the drone has a U of 0 when time is 0, so therefore C is 0. So this is my velocity that I got from anti-differentiating the acceleration, and that will determine the area under the curve for the first 4 seconds. So the integral under the curve for the first 4 seconds plus this rectangle, which is t minus 4 times 4, gives 4t minus 8, where t is the total time. And that will be the distance that the drone moves up off the ground. At the same time, the parachutist is falling and then using the parachute to come down. The last part of the question, they give me the velocity of the parachutist once she opens the parachute. The drone and the jumper are at the same height when the base jumper has fallen 135 metres. So when 135 metres has fallen, they're at the same height. So to find the height of the bridge, it's going to be 135 plus whatever the drone has moved, during that time. And this is the velocity of the base jumper. So I'd like to know the jumper's gone 135 metres in total, and they did 62.5 in free fall. The first bit was 62.5. So 62.5 135 minus 62.5 is 72.5. I found out the time that the parachutist was in free fall. Worked it out, didn't use it though. Find out the time that the parachute was open. So if I integrate this is a velocity time curve. The area under the curve should be distance travelled. So if I could go from 0 to B of that velocity expression, set it equal to 72.5, that gives me a B of 17.4784. I know that the drone will travel this far, and I know that it will be travelling for 17.47, so 17.47 times 4 minus 8 is 61.9. So the bridge will be 135 plus 61.9, or 196.9, which is 197 metres high. That's how question 3 rolls.